So hello everyone, this is Peter Peterson speaking from the Men&Mice side, and with me today I have Carsten Strodman, and together we are delivering this webinar with information on the RIPE 69th meeting, RIPE meeting, and IETF meeting number 91, where Carsten Strodman will tell us about what happened there on specific subjects like DNS, DNS Privacy, IPv6 DANE, DHCP version 6, and other issues he took interest in. Now, Carsten, you are from the services side of the Men&Mice team, is that correct?
Yes, that's so.
Very good. So I'm just here for starting this session, but before I hand over control to you, Carsten, I would like to note that everyone on this attending this webinar is on mute, but you can submit your questions through the control panel of the GoToMeeting application. And please note also that we are recording this session, and you can find both this webinar soon on our website, along with all the previous webinars that we've been doing. You can both find the recording and the slides from these webinars at our website. And so if you drop off this call, you can just go to our website and start listening from where you dropped off at later states. So I don't think there's no reason for any further introduction. Carsten, the audience is yours.
Thank you, Peter. Hello and welcome. This is my report from RIPE 69 and IETF 91. But before we start talking about these two meetings, which happened in November, just something that has been on the news this week. There are important security updates for 3 different DNS server products. They all have the same bug, which is a bug in how they deal internally with following delegations in DNS. So it's a bug in the resolving code. And if you not have done that already, I really recommend to upgrade to the latest version, which is for bind either 996 patch level 1, which is the extended support version of bind, or bind 9.10.1 patch level 1. There's also unbound 151, which is the official patch release, and Men&Mice has released binary installation packages for 1422 patch 1 as well. And for all customers using the PowerDNS recursor, there's the 362. You will probably find updated packages from your Unix or Linux vendor, or if you don't find them there, have a look at support.menmice.com website, where we offer free of charge updated installer packages for popular operating systems such as Ubuntu, Red Hat Linux, Solaris, and macOS. So, about RIPE 69 and IETF 91, one in London, the other one in Hawaii. So I attended these meetings remotely. Unfortunately, I wasn't able to go to Hawaii. It was very busy months in November, and those meetings happened in November, back to back. And I selected here some interesting discussions and reports and presentations that have been done there. If you are interested in the full activities, here are the links to the archives. So you find all the presentations and the videos from those meetings at these links. So we start with DNS, and this time there was a lot of stuff to report, but not so much new RFCs, just one new RFC that have been published since the last report, which was back in September. And that was about automating DNSSEC delegation trust maintenance. Just one RFC, but this is an important one. So I explain what this is about. So with DNSSEC, there is the challenge of doing the delegation trust maintenance. And that means that the chain of trust in DNSSEC needs to be updated whenever the key signing key, the secure entry point in the DNSSEC signed zone, is updated. So nowadays, that is done out of band, that is outside the DNS protocol by some web interface or EPP or some SOAP or RESTful automation interface. Sometimes even it's done manually by sending emails or by other means of copying the key data. Now the IETF have realized that this could be easier, and they came up with two new resource record types, the CDS, the client delegation signer, and the CDNS key, which is the client DNS key record. And both these records can be published in the client's child zone, and the parent zone, which contains the delegation signer, will monitor the child zone, and if new CDS or CDNS key records appear, they will pull the data from there and update the delegation signer in the child. In the parent. Now let's have a look how it is done today. Now here we have a parent DNS zone, which is shown at the top, and a child DNS zone, which is there at the bottom left. And whenever there is a new DNS key signing key, the operator of that child zone creates a delegation signer record by using some tool. In bind, it's DNSSEC DS from key, or it's just being created by the signing command. And this delegation signer record is then sent via a web interface or other means to the operator of the parent DNS. And then the parent DNS operator replaces the existing delegation signer with a new delegation signer. Now, this procedure can be error-prone because it is manual work. It is using some kind of, or maybe some kind of automation, which can fail. So there was the idea to do this exchange of the trust delegation in band, that is in the DNS protocol itself. And this is how it's been done. So the operator of the client of the child DNS creates a delegation signer, which is the hash of the key signing key, and publishes that delegation signer as a CDS record in the child zone. Now the CDS record is exactly the same as the delegation signer record. It has exactly the same fields and this content, just a different record type. That client child delegation signer is then signed with the current DNS key record. So any parent that is then pulling and monitoring the child zone can detect this change, can detect the new child delegation signer, and can pull that out and publish that in the parent zone by just using the DNS protocol and by validating the content by using DNSSEC, because the zone is naturally DNSSEC signed, else it wouldn't have a DS record there. So this is fully in band. No other protocol other than DNS queries are required, and that makes maintenance of the delegation trust much easier than it is today. Currently, we are not aware that there's any implementation of this, but now that this is an RC, we will likely see an implementation of these records and parent DNS zones that use this record and to update the delegation signer in the near future. So more about DNS. Brett Carr at the RIPE meeting reported on the name collision controlled interruption that ICANN is doing. So this is about the new top-level domains that are now being visible in the internet. ICANN is delegating new top-level domains almost every week. And ICANN also monitors this new top-level domain, whether they are colliding with existing names that are used privately, maybe in some private networks. Over the the years, many companies and even home users have used private DNS names, which they just made up, under the impression that these names will never be used in the internet. And for a long time, the top-level domain, the numbers of top-level domains were very stable. Now, new names appear, and the risk of collisions is there. ICANN has found that certain names like .mail, .corp, and .home are so heavily used that they cannot be delegated to a new top-level domain and have been reserved for now. They might be delegated in some distant futures, but not for the years to come, because they are so heavily used, and there would be a lot of these kind of collisions. For noticing these kind of collisions towards the users of these domain names, that is other domain names than the reserved ones, for a few weeks before the delegation, the new names will be used in or will be delegated with a wildcard top-level domain and a wildcard second-level domain, which point with an A record to the loopback address of 127.0.53.53. The idea here is that this IP address will show up in log files and firewall logs, and maybe some administrator will stumble upon them and will recognize that something will happen here or is happening here, and this internally used domain name is now being delegated in the internet as well. So what is the problem? If these names are used internally and also in the internet, data can leak out, because machines that are configured with local names will often leave the controlled network because they are maybe mobile devices, laptops, and so on. ICANN has created a web page that you can see on the slide with more information about this name collision and what they do to prevent the collisions. In the same aspect, and after the talk given by Brent Carr, there was a question whether there is a plan to have a private use domain name similar to the private use IPv4 addresses, the RFC 1918 addresses. And yes, there is such a work in the IETF, and there's one proposal by Stuart Cheshire to reserve the .home special use domain for private use. Now, that is because .home is currently the domain that is used most heavily as the private domain, as you can see here in the statistics, second to Corp, and then SIIT, Global, and so on. And the IETF is working on that. There's no RFC, it's still in discussion, and maybe the second one in the list, Corp, will also be used, because I can imagine that companies that want to use internally a private domain name don't really want to use .home for that, because it has different ring on it. But work is done there, and maybe in the next year, 2015, we might see a private domain for internal use. Geoff Huston from APNIC did more research with his ad network, where he sends advertisements on web pages, and these advertisements do some measurements in the internet. And this time he looked for which resolvers the internet population is using. And in short, the DNS in the internet is weird. So he found out that 41% of all internet clients use non-local resolvers, meaning resolvers that are not in their network but somewhere outside. And the largest DNS services being used are from Google, Level 3, and OpenDNS. And even 1/3 of internet clients use a resolver in a different country. And now this usually cannot be fast, so there are speculations why that is, but it's probably not the best choice to do for both security and performance reasons, but it is that way. You can see the video from this link down here. I highly recommend that. As always, Geoff Huston is a very interesting and good speaker. His work is quite interesting. Sara Dickinson from Synodon presented the new Hedgehog system. Hedgehog is presenting a web UI that presents the data collected from the DNS statistics collector, the DSC system, from the LRoot DNS service. Now, the LRoot DNS server is the root name server operated by ICANN, and there are over 200 instances worldwide of this service. So it's has been a challenge to visualize the data of all the requests that appear on these sites. And Synodon has created a monitoring system that collects all the data, all the DNS traffic going to these root name servers. And there's now a new version out, version 2.0, which, unlike the first version, doesn't require an Adobe Flash plugin anymore to visualize the data and draw the graphs. And the code is now open source under Apache license and can be found on dns-stats.org. Speaking about open source, Geoff Osborne from ISC asked an open question, what would be a good model to finance open source development? Now, ISC is the company behind the bind name server and also the IETF. There had been problems getting enough financial backing in the past. They say no, this is solved, and they are break even. But anyway, it's a problem that not only ISC is facing, but all companies that primarily work for open source. The question is how this can be done. And this talk was not to provide answers, but to give an open question and get feedback from the community. And in the same presentation, ISC and NLNet Labs, they announced that they will team up to provide security announcement and support for customers for both bind, unbound, and NSD. So customers can now get bundles for all the three products from one source. Peter van Dijk from PowerDNS presented a new development in the PowerDNS server that is the Lua policy engine. And Lua is a small scripting language which is very simple to embed into other applications. And the PowerDNS developers, they have put this Lua scripting engine into the DNS server, and now the internal engine, the policy engine of the DNS server, can be changed programmatically. And the motivation here was to implement response rate limiting. We have talked about response rate limiting in one of our webinars earlier this year. It's about mitigating denial of service attacks and preventing denial of service attacks from authoritative servers. Now, with the scripting language inside the DNS server, this is a very powerful way to do decisions on incoming traffic. So, like there can be redirections, traffic can be dropped, traffic can be rewritten, and so on. This feature is still in development; it's not released, and the PowerDNS developers, they request feedback on this, what users really want. George Michaelson from APNIC had a look at the elliptic curve DSA algorithms that are available for DNSSEC. Elliptic curve algorithms for DNSSEC have been standardized by the IETF in 2012, so they are available now for 2 years. But unfortunately, George Michaelson found out that in his measurements that about 1/3 of DNS invalidating resolvers do not support and do not fetch the elliptic curve DSA, which is unfortunate because the elliptic curve DSA would be a good replacement for the currently used RSA algorithms, because ECDSA is more light in key size and also in computing power. So smaller DNS packages, less bandwidth, and less CPU power required, which helps with UDP fragmentation issues in both IPv6 and also IPv4. What he found out during the measurements is that clients still fetch the content even if they don't understand elliptic curve DSA. And this is because the DNSSEC RFC mandate that if a resolver doesn't understand an algorithm, it should treat the zone as unsigned, meaning insecure. So returning the data but not setting the AD flag. And that could possibly be used for a downgrade attack. But even more severe, the users and also the operators of these validating resolvers don't see an issue. they don't get the information that the zone is signed and could have been validated. Instead, they just get the insecure data. And there was a proposal from the audience to change the behavior of validators from the RFC to, instead of returning the unsecure data, just return a server failed error code, which will put more pressure on the operators to upgrade to new versions. Geoff Huston again did a talk about could surveillance be measured, and this is a fallout from the measurements that he and George Michaelson is doing with the ad network. They're using their unique URL names, which should only be fetched once by the client that has seen the advertisement, because every advertisement gets a unique URL to fetch. But they see in the log files that there are shadow fetches from the measurement URLs, which only should see the client should see. But consistently, some seconds after the original fetch from the client, they see some other machine in some other networks to fetch the same URL. And these fetches came from countries like China, Iran, Laos, Macau, Singapore, but also UK and Taiwan and a lot of other countries. And coming from the networks of ChinaNet, a lot of stuff is coming from there, but also Google and RIM, the manufacturer of the BlackBerry devices. So this is curious, and someone is there stalking the internet users, fetching after some time the original content and looking at the content. So looking what other people are looking at. DNS Privacy. Now in DNS Privacy, there's this working group, the DPRIVE working group is still at the beginning. There's a lot of discussion on how DNS can be, how privacy in DNS can be made better. And there are multiple proposals, and the three I've listed here on different way how to do this. And I will report deeper on that once there is a clear roadmap in the DNS Privacy Working Group. There was time ago a discussion in the IETF about the DNSSEC negative trust anchors, which is a way to disable DNSSEC validation for zones that are known to be broken, and known to be broken from the operation side, not broken by attacks, because these broken zones sometimes take multiple days to be fixed, and an operator of a DNSSEC validating resolver would like to selectively disable DNSSEC validation on the zones which are known to be to have a broken DNSSEC. And this can be done with negative trust anchors, and negative trust anchors allow to provision DNS validators from a central point, so that not every validator needs to do a manual negative trust anchor configuration. The IETF has adopted a new document on the negative trust anchors, and work is now starting again, and we hope that this time it will go through as an RFC, and we will have a standard for negative trust anchors sometime in the future. And there's more work on DNS transport over TCP. The engineers at the IETF, they hope with TCP, DNS over TCP, they will be able to help with the privacy efforts, also prevent amplification attacks, which are mostly possible because of UDP source address spoofing, and also go around the packet size limitation that are currently there. A bigger problem that we will see later when we talk about IPv6 is the blockage of extension headers, especially of fragmentation in the internet. And DNS cookies, that is work which is already implemented in bind 9.10. It's about every request having a specific OPT data record that is being sent out in the query, and the answer must contain the very same cookie. and a client or a caching server resolver will only accept an answer that contains the same cookie data. That's implemented in bind 9.10 as the bind source identity token, and it is hoped that this will mitigate denial of service attacks, traffic amplification, and also cache poisoning attacks, because a cache poisoning attacker would then need to guess the value of the DNS cookie beforehand, and with the data in the DNS cookie being random and large enough, that is difficult to do for an attacker. And Mark Andrews, one of the main developers of the binding server, he did an extensive test to find out about the EDNS compliance of DNS servers in the internet. EDNS, that is the extended DNS, which have been around since 1998 in the internet, so for a long, long time. But still, many DNS servers and also middleboxes like firewalls do not handle unknown EDNS options or versions well. They do support the current EDNS, which is EDNS version 0, and they do that just fine. But the idea of EDNS is to be able to incrementally introduce new features with new EDNS version numbers. And that is broken, so a lot of middleboxes and routers and CPE devices and other DNS servers, they just don't respond or respond badly if they see an EDNS version other than version 0. And this is a problem that the internet engineers at the IETF need to deal about. About DANE, on the IETF meeting, there was a demo of an S-MIME client, a prototype, based on the GetDNS API, and it's a plugin for the Mozilla Thunderbird mail client. And with this plugin, it's possible to encrypt via S-MIME the content of an email by just using key exchange and key negotiation using DANE and DNS execute DNS. So there's a lot of happening in the DANE space. Dan York from ISOC, he gave a presentation on the DANE deployment observations, the good and the bad he has seen in and others have seen in the DANE deployments. On the slide example here, the DANE success story, that's the good part, but there are also some bad parts, things that don't work as expected. And you can have a look at these slides if you are interested in that. And there was much more DNS, much more that I could put in this presentation here. Chris Baker from Dyn reported on abuse on dynamic DNS. Attackers use dynamic DNS services for command and control servers or fast flux networks, putting wildcards in there. Nicholas Carton from Efficient IP, he gave a presentation overview on current best practices on how to mitigate DNS attacks and how to run a good DNS infrastructure. And that is a presentation that is full of good advice about current best practices on how to run a DNS service and DNS designs. So if you operate DNS, that might be a good presentation to watch. Andrew Kaletka from CZNIC presented about challenges with endpoint DNSSEC, about DNSSEC validation in applications or directly at the endpoint. Problem here is that operators in their firewall strip out DNSSEC resource records or implement a transparent proxy which blocks some of the DNSSEC traffic. And Jaap Akkerhoes from NLNet Labs, he reported on NSD 4.1, which now has the feature that it's not mandatory anymore to precompile the zone, which is a huge relief on the memory consumption on NSD. So it uses like 50% or even 60% less memory than previous version, with the performance penalty on about 3%. It's still possible to precompile. Then you have the maximum performance. But if you don't want to trade memory for performance, you can now load zones in NSD without precompiling them. And that was DNS. which brings us now to the next topic of DHCP. There was also just one RFC published since last IETF, which was the DHCP v4 over DHCP v6 transport, which means that DHCP v4 options can be sent over DHCP v6. A DHCP v6 server delivers options for IPv4 clients. And that enables operators to just run one DHCP service in the network, which is the DHCP v6 service, and they don't require to run both services in the same network, which makes it a little bit more easier, less complexity. The DHCP working group is also working on privacy, and they're currently collecting the requirements and where privacy issues are in danger in the DHCP protocol. So they listed in the initial drafts, which are listed here, the identifiers, the MAC addresses, and the UIDs. They listed some attacks and how information about networks where the client has been before can leak out to new networks. And they made a work plan over the next year when they want to have certain goals reached with this new RFC. And there was a new draft on, or not a new draft, a new update on the draft on issues with multiple stateful DHCP v6 option. And this is about that DHCP v6 servers can have multiple options that require the server to hold a state on the server. That is the IPv6 addresses, and it's also the prefix delegations. Now, how should a server handle if there are different, like, lease times on prefix delegations and the addresses? And this draft lists some suggestions and recommendations what server should do, and also how a client should do if they get multiple options that are stateful. And last but not least, the IPv6 and IPv4 sunset. So there was quite a number of new RFCs being issued. First one is the IPv6 service continuity prefix, which is the 192.0.0.0/29, and that is a prefix that is set aside for operators to use in their internal networks for bridging bridging islands of IPv6 or bridging islands of IPv4, for example, with dual stack light. And because there are some operators that are so scarce on IPv4 addresses that they don't have any to spare, and they cannot use the RFC 1918 addresses because these addresses might be used in the home networks they service. Now this prefix is set aside for them to use on these transit networks. And they can use any number of the same addresses on these transit networks if they just don't appear in the same collision domain or in the same link. Then there's a new IPv6 prefix for the ORCID, for the overlay routable cryptographic hash identifiers. There is an update to IPv6 multicast, the next two RFCs, 7346 and 71, which specifies a new scope, which is the realm scope, which is especially used in mesh networks. So in addition to the node local, link local, global scopes and site local scopes, and now we have this realm scope, which is scope number 3. And then there's an important RFC being published. It's informal, but it's a very good document about enterprise IPv6 deployment guidelines. So every enterprise that would like to deploy IPv6 and needs some information, guidance, best practices from people who have done that, they can read this RFC and find tons of good advice and good information on how to deploy IPv6 in an enterprise network. And the last one, 7404, is about using link local addresses only inside an IPv6 network, especially here on router-to-router links. Because in IPv6, you can have all the routings, all the routing protocols use the link local address as the next hop address. So it's not required to give the routes actually real global routable or even local addresses. Just the link local addresses, the FE80 addresses are just enough. And this RFC document describes how that can be done, what pitfalls to avoid there, and why it might be desirable to do it that way. On the right meetings, Jen Linkova from Google presented about stop thinking IPv4, IPv6 is here, and she listed all the points, or a lot of points, that should be considered to move to IPv6. And her point is it's not a question whether we should deploy IPv6, it's just a question how to deploy it and when to deploy it. And people need to understand IPv6 in a broader fashion to be able to decide whether they want to use it or not to use it. Just having people not looking at IPv6 and then saying, "Oh, we don't want this," is maybe a bad choice, because there's a lot of goodness in IPv6. And I won't go into these details here. Anyone who is not already in the full swing of going to IPv6 should see this presentation and take some of the good advice here. It also has a recommendation for a good free book. It's called IPv6 for IPv4 experts, and this is a book for network administrators. It takes the IPv4 knowledge and transforms that into IPv6 and helps to get the first steps into IPv6. On the same, Tor Anderson, he gave a presentation both on the RIPE meeting and on the IETF meeting about stateless IP and ICMP translation for IPv6 data centers. And the idea here is that data center operators don't want to run two network protocols in their data center. They don't want to run a dual stack IPv4 and IPv6 side by side, because there is much more complexity and much more that can go wrong. It's mainly almost double the work. So it is desirable to only use IPv6 in the data center and to push IPv4, which we still need for some clients that are only IPv4 enabled, push that out to the edges. And the idea here is to have stateless translators at the edge, that is at the edge of the data center, to translate incoming IPv4 traffic into IPv6 traffic by encoding the IPv4 addresses into an IPv6 prefix. And that can be done without any state, because on the way back, these translators can just take the IPv4 addresses out of the IPv6 address, out of the prefix, translate that back to IPv4, and that can be done in the same way as IP routing is done. So that can be done with the same line speed as IP routing is done today. It's already supported by Taiga, which is an open source gateway, IPv4, IPv6 gateway for Linux. It also implements DNS 6.4 and NAT 6.4, and available in some commercial routers. I've done such a deployment in a smaller scale, not a really big data center, but like a data center type of deployment with a few servers just last month, and I must say it's working really, really well. It's really nice to have a system and a data center only on IPv6 that is just easier to maintain than a dual stack system. Jen Linkova again, together with Fernando Gont and others, presented on IPv6 extension headers in the real world. Measurements have shown that a lot of IPv6 packages with extension headers get dropped on the transit. And that is a big problem. It's a problem for DNS, where fragmentation can happen, and then because fragmentation requires the fragmentation extension header in IPv6, the fragmentation just gets lost on the way, and the DNS data gets lost. And currently, we see a lot of this, and the IETF is working on solutions here and also educating network operators to not drop and not filter IPv6 traffic just based on extension headers. Jen will repeat the same test that she has done this year, next year, to see if there's improvement or whether it actually gets worse. And there was more work on IPv6 at the IETF. A document about problems observed in IPv6 only deployments. This is mostly because there are some operating systems and applications that just expect IPv4 always to be there, and they don't work really well with IPv4. And this document highlights where work is still needed and where problems can occur. There's a recommendation on the stable IPv6 interface identifiers, which is an idea to replace the EUI64 identifiers that are made out of the MAC addresses. The problem with the MAC addresses is that MAC addresses and IPv6 addresses that are created from MAC addresses can be monitored across multiple networks. So network operators can monitor machines, mobile machines moving from network to network. And with this stable IPv6 interface identifier, every machine gets, for every network, a stable identifier. So in that network, it's always the same network identifier in the IPv6 address, but that same interface identifier is not reused in any other network. So the client has a unique identifier in every network. There are problems with IPv6 atomic fragments, which are actually a way of doing fragmentation with just one fragment. There was an idea early in IPv6 that can help some fragmentation and tunneling issues where a translation between IPv4 and IPv6 isn't being done. Now, there are some security problems with this that are now known. So the IETF is now working on deprecating these atomic fragments because they are not really needed in the way they are standardized. And there's a new document on prefix length recommendation for forwarding, meaning that transit networks should not filter on the prefix lengths when they do forwarding in the routers. And some miscellaneous, which doesn't fit in all the normal chapters we have. There was Jason Schiller from Google presenting QUIC. QUIC is a way to load web pages over UDP using multiplexed connection over UDP. The problem that they want to solve here is that load performance over TCP has some issues, and these issues cannot be easily solved with TCP. So Google is experimenting here with UDP, and they have implemented that as part of the Chromium project, the Google browser. It has the similar function or same function like SPDY, which is also a new protocol for HTTP called HTTP, or SPDY is part of HTTP2 standardization. But what's interesting here is that this new QUIC that is loading HTTP over UDP is already or will be supported in future Chrome browsers starting early next year. And most Google websites are already QUIC enabled on the server side. So we might see in networks where Google browsers are being used switch from TCP to UDP for all traffic going towards Google. And there was a comment from the audience that port 80 UDP might be blocked or is blocked in some networks. And because of that, Chrome implements a TCP and UDP happy eyeballs, meaning the browser will start creating a connection both on UDP and TCP, and it will use whatever connection is the fastest one. So if UDP port 80 is blocked, then the TCP will win. But if UDP port 80 is free and be used, or if port 443, the HTTPS port is used, then UDP is usually faster and that will be used. This is important information, I think, for firewall administrators, because UDP connections require more state in the firewall, and more UDP traffic can lead to performance bottlenecks in some firewall installations. So if you have customers, users that use the Chrome browser, just be aware. And Raymond Cheng presented about uProxy, a social proxy for browsers. The idea here is to have a peer-to-peer network between browser users using a plugin that is available for Chrome and Firefox to be able to piggyback and reuse a network connection from another user, from a friend. And there are several use cases here. For example, someone that is in an insecure Wi-Fi could create an encrypted and secure channel to a machine running a browser at home and using the network at home for all the browsing experience. So all the traffic seems then to come not from the Wi-Fi but from the home network. And that is implemented using WebRTC as the underlying transport, which is the new technology which is now implemented in the browsers. It's implemented there for real-time communication, for chat and video chats, but it can also be used for this to create encrypted tunnel, and this is an interesting technology. And like people from the audience pointed out, this could be get some stir up in the commercial content community about geolocation, because it's an easy way to run a proxy and to circumvent geolocation logouts. So people like watching television or movies from countries where a certain service is not available. So this was my overview on the RIPE 69 and IETF 91 meetings. We will continue having our webinars next year. And here are some ideas that we have on topics that we want to present next year in our webinars. So this is not a promise, just some ideas. And we would like to have your feedbacks on this. And if there are some topics here that you would like to see and it's not listed, please let us know. So we want to talk about DNS resolvers, resolver monitoring using DNS TAP. DNS TAP is a new technology that allows to hook into a running DNS server and extract data from the state of the DNS resolver without impacting the performance of the DNS server. And that is now implemented in Unbound 1.5. And you can think about that as like query logging, but much better because it gets much more data and it doesn't slow down the DNS server. The Men&Mice suite now has a generic DNS controller, which can be used to control other name servers other than Microsoft DNS and Bind, which we have supported for a long time. For example, PowerDNS or the Amazon Route 53 Cloud DNS. But it's also possible to support other kind of DNS servers here. We won't like to tell you how that is being done and what's possible there. There was a topic called selective blackholing, which we had on our list for the RIPE 68 review back in May, which we had to drop because of time constraints. We want to bring that back with a whole webinar on this. This is DNS of service mitigation and blackholing DNS of service sources. We will do a webinar on DANE and DNSSEC revisited. There's a lot of work and a lot of changes happening in DANE and DNSSEC, and probably after summer 2015 we will have a webinar on what has changed, what is new on these topics. We will talk about the KNOT DNS server from SIIT-DC, a new authoritative DNS server which is both fast and easy to use. It's open source, and we will talk about that, and we'll tell you what is the difference between this server and established name servers like the Bind name server or NSD. We will continue with the RIPE and IETF meeting reports. We'll talk about Bind 9 tuning and give an update on new Bind versions like the new Bind 9.10 and Bind 9.11 or 9.12 and how to use GeoIP with Bind 9. And if there's some topic you would like to see here, just let us know, send us an email, or contact us on Twitter or Facebook. Having said that, are there any questions?
Carsten, there is a question here.
Peter, have you
Yes.
seen any questions? I haven't. Okay.
There is a question here. It is regarding DANE, whether you are seeing a lot of application developed for DANE and how you see the uptake, moving forward.
Well, that I can only talk about Germany, because I've been to many conferences in the last half year in Germany, mostly about talking about DANE, and there is definitely interest from all kinds of organizations, government organizations, enterprises, private people, and we see good deployment rates here. So we see both smaller companies and larger companies going there. The largest here in Germany is probably Unity Media, with some 500,000 probably customers on the mail system. But also we know that other operators and mail services are working on this. So yes, there's quite a number of interest in DANE for email, for SMTP. And the DANE working group is very active, bringing out new DANE proposals like the SMIME. And SMIME is especially interesting for enterprises, because it allows end-to-end email encryption in a controlled and organized way. Easier to manage than PGP end-to-end encryption. So that is where a lot of enterprise companies are waiting for.
Very good. That sounds exciting. Well, I'm not seeing any other questions. Anyone on the call that has an extra question, you can submit that through the control panel. So, Carsten, I don't see any additional questions appearing. So, just to recap, we have been recording this webinar, and we will put that recording on our website along with the slides shortly. So, thank you everyone for attending. And Carsten, you want to end with the Christmas greetings?
Yes, I wish all our listeners here to the webinars happy Christmas season and a good new year 2015, and see you all again next year.
Thank you, Carsten, and thank you everyone.
Bye for now. Thank you, Peter.
Yeah, thanks. Bye.